This is lesson 7.3, Simplifying and Graphing Equations and Expressions with E. E is going to be something new that you most likely have never seen before. It's new with Algebra 2. What is E? Well, E is similar to pi in that E is just a number. So E stands for 2.7182812. Let's see, try it again. 2.7182881. That should be an 8 there. Not that you guys care, but it continues on in that pattern, and we approximate it as E is 2.71. Just like with pi, we generally say pi is 3.14. So with E, we're going to say E is 2.71. Now, most of the time, though, we're not going to approximate it at all. In a lot of these examples and a lot of the problems on your homework, E is just going to be a variable. So for your first example, if E is to the negative fifth power times E to the second power, we're going to keep E as our base. And then since it's a multiplication problem, 2 bases and 2 exponents, we're going to add the exponents. That equals E to the negative 3 power, and anytime you have a negative exponent, we rewrite that exponent into the denominator. So E to the negative 3 becomes 1 over E to the positive 3. And that's the expression simplified. So notice we're just leaving E as a variable. For your next example, we have E to the fourth to the negative third. And anytime you have one base and 2 exponents, you multiply. So 4 times negative 3 is negative 12. Since my exponent is negative, I'm going to rewrite it as 1 over E to the positive 12 power, and that's my solution. For this next problem, we have more than one thing going on. We have some division on the inside of my problem, and then it's to the second power. So let's deal with the inside part first. 3 divided by 6 is 1/2. E to the third divided by E to the second is E to the first. And then all of that is still going to be squared. Now I'm going to distribute the square to each part of my problem, so it's going to make this be 1/2 squared times E squared. And 1/2 squared is 1 over 4. And E squared is still E squared. So my solution is 1/4 E to the second power. So that's simplified. Some of these problems are going to be really unusual. When we look at this next problem right here, we have a square root. So you're just going to kind of think a little bit about this. What is the square root of 9? Well, it's 3. What is the square root of E to the fourth power? Well, E to the fourth power comes from E squared. So the square root of 9E to the fourth is 3E squared. So we've simplified that part and made an easier problem. Now I have 3 and 2, so that makes 6. 3 times 2 is 6. I have 2 bases, so I add my exponents, so that's 2 plus negative 3, which is negative 1. If I have a negative exponent, then I move that part to the denominator, so 6 stays where it is. E to the negative 1 becomes E to the positive 1 in the denominator, and you can leave the 1 off. You don't need it in the exponent. So 3E squared times 2E to the negative 3 became 6 over E. Alright, now we're going to do an example of graphing. This function is 3e to the x, and we're going to pick a couple of x values, and I mean just a couple. About 3 is probably all you need. You definitely need to make sure that 0 is always one of your x values. We're going to plug them into our equation, and then we're going to graph this, and it's going to look a whole lot like what you graphed in 7.1. So f of x, if x is negative 1, that would be 3e to the negative first, which is 3 divided by e, which I have to put into my calculator and approximate, and I get 1.1 for that. So when x is negative 1, y is 1.1, so I'm going to go just above, put a dot just above where 1 is. When I plug in 0, I get 3e to the 0 power. Anything to the 0 power is 1. 3 times 1 is going to be 3. So at 0, I go to 3, there's my dot. And then when I plug in 1, that's going to be 3e to the first, which means I'm going to have 3 times 2.71. And 3 times 2.71 is about 8.1. So when x is 1, it's going to be way up here, and I've actually gone into off my page almost. So when you look at this, it just comes through like this, and it has that same angly shape that we saw in 7.1 because it's the same type of problem. The reason they use E to stand for this 2.718281828 is because E could be for exponential, and these are all exponential equations. Now notice that this equation is going up, so it is growing. So an equation that looks like this is a growth equation, and that always happens when the exponent up here is positive. If you have a picture that looks like this, where it is like going down a slide, that is called decay. And that always occurs if my exponent up here is negative. So a positive exponent is growth. Excuse me if I messed that up. And a negative exponent is going to be decay.